Hello everyone, I'm Satyajit and welcome back to my channel. You're watching the Python course playlist and today's video is on iterators and generators. I hope you're already clear with the previous topics. If not, please go back to the videos in my playlist and study them. Link to the videos are already in the description below. If you're new to the channel, please subscribe and hit the bell icon to get notified on my future videos. So let's get started. So far, we have already covered the concepts like data structures. We understood what is tuple, what are lists, dictionaries, sets. We also understood various file handling functions, how to handle files, how to read files, how to write files, and exception handling. A lot more topics were already covered, functions, lambda functions, and all those things. If you haven't covered it so far, please go back to the previous videos and learn it. Today's video is all about iterators and generators, which is the fifth chapter of our Python course playlist. Okay, so let's try to understand what iterators and generators are. Now, obviously, in the previous classes, we have also talked about iterable object when we were dealing with a map reduce functions, right? So we also know as of now that what is an iterable object. A list is an iterable object. A dictionary is an iterable object, right? So iterator in Python is simply an object that can be iterated upon, an object which will return data one element at a time. Okay, it implements two special methods internally, which is iter and next. Together it is called as the iterator protocol. And what is a generator? Generators are simple way of creating iterators, I would say. And basically it's a function that returns an object, iterator object, which we can iterate over one value at a time. That means we will try to understand what exactly is the main functionality of generators. Theoretically, it is a little bit difficult for me to explain you. Now, if a function contains at least one yield statement, it may contain yield or return statements, it becomes a generator function. Okay, we'll quickly go through generator functions in practicals so that you get an understanding what is the difference between the basic function and a generator function. Okay, in this section of the course, we will be learning the difference between iteration and generation in Python and how to construct our own generators with the yield statement. Okay, so yield is the keyword here, which we will be using, and that makes a function a generator function. Okay, generators allows us to generate as we go along instead of holding everything in memory. Now, what does that mean? We'll come to that. So we have touched on this topic in the past when discussing certain built-in functions, Python functions like range, map, filter, etc., etc. So let's explore a little bit deeper. We have learned how to create functions. We know how to create a function using a def keyword, and we know how to return something, right? Using the return keywords. So we already know about def and return statements. Generator functions allow us to write a function that can send back a value and then later resume to pick it up where I left it up or where the developer left it up. Okay. This type of function is a generator function in Python, allowing us to generate a sequence of values over time. The main difference in syntax will be the use of yield statement. Okay, we'll see. So in most aspects, a generator function will appear very similar to a normal function. The main difference is when a generator function is compiled, they become an object that supports an iteration protocol. That means when they are called in your code, they don't actually return a value and then exit like your normal function. Instead of that, generator functions will automatically suspend and resume their execution and state around the last point of value generation. Again, hold on, we'll talk about the practicals, then only we'll have a better understanding of generators. Okay, the main advantage here is that instead of having to compute an entire series of values upfront, the generator computes one value and then suspends its activity awaiting the next situation or the next instruction. This feature is also known as state suspension. Okay, make a note of it. This is also known as state suspension. Okay, let's get back to work. Let's go ahead and try to implement the practicals because that's more important. So I have already written down find cubes of number. So we'll see how to create cubes using normal functions, and we'll also see how to create using generator functions. Now, how to create using normal functions? Maybe if I write down a function gen cubes, okay, makes it for num in range of n print num. Okay, and then I will define gen cubes 5. Okay, my bad. I didn't do the cubes, right? So this is how it is printing the output. Now I don't have to explain you what exactly a for loop is, because we already know what is a for loop, what is a range function. Now what is a range function? Let me show you that. Now range function is nothing but for I in range of n, print I. I missed out I here. So range of n means it will print from 0 to n minus 1. Okay. Oh my god. So I have to make it some value so that it's not n. Okay. For I in range of 5, it is printing me 0, 1, 2, 3, 4. Okay. 5 values, but starts from 0 index till 4. Okay. So let me just remove it. Similarly, it is taking 0, 1, 2, 3, 4, and it is generating the cubes 0, 1, 2, 3, 4. Now how to write down using a generator function? Let's create a generator function. I just copy paste the code here. Instead of print here, I'll write yield num into 3. Okay. And after that, what I'll do is for x in gen cubes 5 print x. You can see, right? So this is basically a generator function. Now, since we have a generator function, we don't have to keep track of every single cube we created, right? So generators are best for calculating large sets of results, particularly in calculations that involves loops themselves, right? In cases where we don't want to allocate the memory for all the results at the same time. Now let's try to create another generator function, which let's take a small example. Let's take Fibonacci series. Okay, let me write it down. Sorry, this one. Fibonacci series. Now everybody knows about Fibonacci series. If you don't, simply go to the Google and try to understand what is Fibonacci series. So it basically means it is the sum of the previous values. In mathematics, the Fibonacci numbers, commonly denoted f, form a sequence called Fibonacci sequence, such that each number is the sum of the two preceding ones, starting from 0 and 1. Okay. So let's try to create a generator function for Fibonacci series. Gen Fibonacci n a equals to 1, b equals to 1 for I in range of n, yield a comma b equals to b comma a plus b. Okay, I've created my function, and then similarly like this, I will call my generator function. Instead of gen cubes, I'll call my gen Fibonacci and print it out. You can see initially for 0 it is printing 1, then 1 plus 1 2, 1 plus 2 3, 3 plus 2 5, 5 plus 3 8, next will be 8, next will be 13, right? If I just pass 8, 13, then 21. Okay, this is basically your Fibonacci series. Let's do it for 10. Okay, so 8, 13, 21, 13, 21, 34, 34, 21, 55. So this is basically Fibonacci series. Now obviously let's try to see how to create a Fibonacci series using the normal functions. I'll just write definition. I'll make it gen Fibonacci normal n equals to 1. Almost similar code, but only thing is that we have a yield function here. Okay, equals to 1, b equals to 1, output equals to, let's create a list for I in range of n, output dot append. I'm appending a here, and then a comma b equals to Okay, should work. And then, yeah, obviously the main thing, which is our return statement, return output. Okay, now if I just call my function, okay, so this is my final output, right? Now notice that if we call some huge value of n, like let's say 10,000, let me call, let's just call 100 for now. You can see obviously the only difference in this and this is that if we call a very huge number of huge value of n, like, so I just call 100, let's say I call 10,000 or 1 lakh, the second function will have to keep track of every single result. Okay, you can see it is keeping a track of everything in a list. You can see the braces, and here you can see there is no such braces. That means it doesn't really care, right? Here it is keeping a track of everything. So if we call some huge value of n, let's say for now I'm just calling 10, and let me write it down in the markdown so that you don't forget. If we call a huge value of n, let's say n equals to something like this. Okay, the second function will have to keep track of every single result. When in our generator case, we actually only care about the previous result to generate the next one. Okay, that's the only difference between a generator function and a normal function. Okay, now let's try to see some of the other built-in functions so that it gives us better understanding on other iteration and generation concepts. So let's try to talk about the next and iter function. Built-in functions. Let me. Okay. Now what is next and iter functions? So a key to fully understanding generators is the next function and the iter function. Now, only when you understand next and iter, then you'll have a very better understanding on the generator functions as well. So the next function allows us to access the next element in a sequence. Let's check it out. Okay, I'll just create a simple generator function. I'll keep it open for x in range of 3 yield x. Okay, now here what I'll do is assign some values. So I'll just call let's say x equals to this function. Now if I print next of x, it's printing me 0. Let's print next of x again. It's printing me 1. Next, it's giving me 2. So it stopped its iteration. You can see stop iteration. Now why is it so? Because we have defined this function as a range of 3. That means 0, 1, 2. Okay, so that's how your next operation works. Next built-in function works. Okay, so after yielding all the values, next caused a stop iteration error. What this error informs us is that all the values has been yielded so far. Okay, so one thing is definitely for sure that you would be wondering that why don't we get this error while using a for loop. Now you can write down in the comment section below if you have any idea about that why don't we get this particular error when we run it in a for loop. Because for loop automatically catches this error and stops calling next. So that's the beauty of the for loop. Okay, let's go ahead and check out how to use iter built-in function. Now to explain about the iter function, I'll just remind you about something. I think you must have remembered about the strings, right? The strings are iterables, right? Because ultimately when you iter through a string, each character is iterated. So let's just define a string. I'll just write down iter. Here I will write down Okay, for better understanding, next iter. So let's talk about string. So x equals to hello. I have defined s as hello. Now for, okay, my bad. Okay, so s equals to hello. Now for x in s, that means for each element in s, print x. So it is printing me all the characters in a sequence, right? But does that mean our string is an iterator itself? Now let's try to see the next function here. Now if we get an output of next, like here we got an output of, like here what we were doing here is for x in range of this, right? So for x in range of s. So can we, sorry, can we get the output? No. So that doesn't mean that string is an iterator itself. You can see string object is not an iterator, right? Interesting, right? This means that a string object supports iteration, but we cannot directly iterate over it as we could with a generator function, right? I hope it's clear. So the iter function allows us to do this activity. We'll have to use the iter built-in function so that we can iterate through a string. So let's create a string iterator. Iter equals to iter of s. That means this is my string. So here I'm able to see, okay, I'm just explaining you again. So what we have done is I have created a string here, hello, for x in s, print x. That means it's printing each character one by one. Now, what I asked 2 minutes back is, does that make a string an iterator? So if it makes it's an iterator, then our next built-in function should also work, right? Like it worked here, 0, 1, 2. But here, when we ran the next operation, it throwed me an error that type error, string object is not an iterator. That means string itself is not an iterator, but it supports iteration. But if it supports iteration, then how to iterate? Let's try to understand about the iter built-in function. Okay, so I've created iterator here. Sorry, iter function here. String iter equals to iter of s. Let me run this. Then I will do call my string iter. You can see h, sorry, e, l, l, o, stop iteration, right? Exactly like this. So here we were able to iterate it easily. In a string, iteration is possible. That means it allows iteration, but it itself is not an iterator. That is the reason to iterate through a string, we have to use our iter built-in function. Okay, so I think it was a great session from my point of view, obviously. Yeah. So now you know how to convert objects that are iterable into iterators themselves. The main takeaway from this lecture is that using the yield keyword at a function will cause the function to become a generator, which I think most of you are clear with right now. This change can save you a lot of memory for large use cases. Obviously, our ultimate goal is data science, working on machine learning. So there will be a lot of data coming in, right? So you have to understand how to write down a generator function instead of writing a generic function. Okay, so because it helps us save a lot of memory for large use cases. Now, for more information on generators, I will leave two of the links in my description below so that you can access it and understand more about generators. But I think for an intermediate level of understanding, this video is more than enough. So thank you guys. Thanks for watching. Our next session will be on Python for data science, which is going to be very interesting for you because that's what we have waited for so far. So stay tuned. Uh, Please like the video. Please share among your friends and subscribe the channel. And that's it. Keep supporting. Thank you.